Welcome to Daily Papers, the podcast where we break down fascinating new research into bite-sized pieces. Today, we're talking about teaching an AI to memorize a library.
An entire library? That sounds intense. My brain feels full after reading a single instruction manual. How can you possibly get an AI to absorb that much information and actually remember it?
That's the multi-billion-dollar question, and it's what today's paper is all about. The paper is called Data Quality Over Capacity, Internalizing Documents into LoRA Adapters for Closed-Book QA.
Okay, that title is a mouthful. Let's break it down. What's the usual way you get an AI to answer questions about, say, a specific set of company reports or medical journals it wasn't originally trained on?
The standard method is something called Retrieval Augmented Generation, or RAG for short. You can think of it like an open book exam. When you ask the AI a question, it first quickly searches through all the documents to find the most relevant paragraphs.
So it retrieves the info.
Exactly. Then it uses those paragraphs, that context, to generate its answer. It's very powerful, but it has drawbacks. The search can be slow, and what if it pulls up the wrong information? Then your answer is going to be wrong.
So the open book exam isn't foolproof. What's the alternative this paper is looking at?
The alternative is what they call knowledge internalization. This is the closed book exam. Instead of searching for the answer every single time, you train the AI to actually memorize the information from the documents and store it directly in its own parameters.
You bake the knowledge right into the AI's brain. So when you ask a question, it just knows the answer, no searching needed. That sounds way faster, but is it even possible to do that effectively?
That's what the researcher wanted to find out. They didn't want to retrain a massive language model from scratch. That's incredibly expensive. Instead, they used a clever technique called LoRA, which stands for Low Rank Adaptation.
LoRA, what's that?
Imagine a giant, complex machine, like a factory. To teach it a new task, you don't want to rebuild the whole factory. A LoRA is like a small, efficient plugin or adapter that you attach to the main machine. You only train this tiny, efficient plugin, which is much, much cheaper and faster, but it still lets the whole factory learn a new skill.
Got it. A small, trainable brain extension for the AI. So they attached one of these LoRA adapters to a language model and tried to get it to memorize a collection of documents. What did they find? What's the secret recipe?
Well, this is where it gets really interesting. You might think the most important thing would be the size of the LoRA adapter. In their words, its capacity. A bigger adapter, or a higher rank, should be able to store more facts, right?
That makes sense. More storage space for more knowledge. Or maybe they needed some super complex new training technique.
That's what they thought they might find, but they ran about 100 different experiments, and the results were crystal clear. The single biggest factor for success wasn't the size of the adapter or the training recipe. It was the quality of the training data.
The quality? You mean the documents themselves?
Not even the documents, but the question and answer examples they used to teach the AI. In their first attempt, they had an AI generate these Q&A pairs, but the answers were often long, wordy clauses and included lots of random trivia. The model trained on this data was not great. It only scored about 58% on accuracy.
So what did they do to fix it?
This is the best part. They did what they call a single curation pass. All they did was go through the training data and clean it up. They shortened the answers to be very direct and concise, just 1 to 6 words, and they threw out the unnecessary trivia. Simple housekeeping, really.
And did that little bit of tidying up actually make a difference?
A massive difference. After training on this new, clean data, the model's accuracy jumped from 58% all the way to 86%. That's a 28-point increase just from making the answers shorter and more direct. This one simple change was more effective than any other architectural tweak they tried.
Wow, so it's not about building a bigger brain, it's about giving it better, clearer notes to study from.
Precisely. They found that once the LoRa adapter was big enough to handle the task, making it even bigger gave diminishing returns. The bottleneck wasn't capacity, it was learnability. The messy, long-winded answers were just too hard for the model to learn effectively.
So how did this new memorizing AI stack up to the old open book exam ROG system?
It blew it out of the water. On their 15-document test, their internalized LoRa adapter was not only about 25 points more accurate than the RAG system, but it was also significantly faster because it didn't have to do that slow retrieval step every time.
That's a huge win. So does this mean we should just focus on data cleaning from now on and forget about everything else?
Not quite. The paper does offer a few other important lessons. They found that as you add more and more documents to your collection, your corpus, you do need to increase the LoRa adapter's capacity.
The backpack needs to get bigger as you add more textbooks.
A perfect analogy. They also discovered a neat little quirk. When they made the adapter bigger, they also had to make it learn more slowly. They had to use a gentler learning rate. If they didn't, the performance actually got worse.
So a bigger brain needs to take its time and learn more carefully. It's funny how these things sometimes mirror how we learn.
It is, and the researchers admit they were even fooled by this at first, thinking the model had run out of capacity when really it just needed a gentler training approach. It's a great little case study in how to debug these complex systems.
So what's the big takeaway from this paper?
The main finding is beautifully simple. When it comes to teaching an AI to internalize knowledge, the humble, unglamorous work of curating your data, making it clean, simple, and direct, is often more powerful than just throwing more computing power at the problem or using a fancier architecture.
Garbage in, garbage out, as they say. Or in this case, high quality, concise data in, high accuracy, lightning fast answers out.
Exactly. It's a powerful reminder that sometimes the most mundane-sounding task is actually the most important one. Data quality isn't just a side issue. In this case, it was the main event.